So hi everyone, thank you very much for joining today's webinar on the sustainable telco network dilemma, matching net zero goals with exploding customer demand. So today we have quite a packed agenda, so we'll try and keep the introduction as short as possible. But we'll start once the introduction's finished with a presentation from SCL partners. That's backed by an extensive research program that has been ongoing for the past few months. And then we'll move to Juniper's presentation and Amit will take us through that. And then we'll have time for panel discussion and audience Q&A at the end. So just a little bit of background on the webinar, because I'm sure not all of you are familiar with it. So essentially, you're all in listen only mode. But if you do have any issues with audio, please leave us a comment in the questions tab and one of our team members will assist you. We have a Q&A session at the end as mentioned, so please feel free to submit any questions for our presenters throughout the session. That's also available using the questions tab. And everyone who's registered for this session will receive the slides, the recording shortly after the session to watch back and to share with colleagues. If you are on social media, please feel free to tweet us at SCL Partners. So a little bit of background on our panelists. So of course we have Phil from SCL, the Managing Director of Consulting. We have Amit from Juniper, so VP of Product Management. We have Terje from Telenor. So SVP Network and Cloud Technology Strategy, Ahmed from Vodafone Egypt, who's part of the Tech Center, Senior Solution Architect, as well as Lalit from Lightstorm. And I'm sure not all of you have heard of Lightstorm. So it's a relatively new operator, but they're growing incredibly quickly. They're based in India with operations in multiple jurisdictions, particularly in Asia. And they built a network with cloud in mind, both as a customer and as an enabler. So essentially, they can be quite well described as a data center neutral carrier. We do urge you to check out all the panelists on LinkedIn while we're going through the slides and also after the session. But yeah, really looking forward to this. So if we move on, I'll pass over to Phil to take us through SCL's presentation.
Great. So thank you, Will, and welcome everybody. Good morning, good afternoon, good evening for some of you dialing in from Asia. So what I'd like to do today is just set out very briefly some of the key thoughts and findings. The situation that we face ourselves in industry, you're all familiar with. We are seeing significant and increasingly unpredictable growth in traffic. So this traffic is heterogeneous, it's unpredictable, and it's distributed. We're seeing AI and the growth in AI and IoT and in gaming is amongst the drivers there. So we all know this, and we all know it's increasingly difficult to predict what and how those patterns are. At the same time, most operators globally are at least reporting, and many of them setting clear net zero targets. So they have sustainability commitments. And what we're finding is that a lot of operators are making good progress on the quick wins, as we say, but as they get beyond those quick wins, it becomes harder, partly because the reporting rules are becoming tighter, what counts as emissions is becoming, the definitions are becoming stricter, but also you've taken the first easier steps, and then the steps are getting harder when it comes to decarbonizing the network. So the key question is, you want to avoid the bottlenecks, you certainly want to avoid impacting customers and having an impact on their quality of service, and you need to drive down your emissions and obviously maintain margins. So how do you overcome this challenge? And that's really what we're going to be setting out and talking about today. So a little bit of background. What do we do? As part of this assignment, we went and spoke to operators globally about how they were approaching this challenge and what they saw as the key routes to resolving it. So this is the geographic coverage of the research, and here are some of the roles of those involved. So that's a little bit of background about the research, and now I'm going to just sort of share the key findings of that research and the wider work that STL Partners has been doing over the years around this topic. So the broad sort of finding is that and this is an oversimplification, but the traditional economics of networking are such that as you increase demand, or as the orange line here on the left, demand increases for services, in line with that, so do the resources required to support that. And I guess the challenge we are faced with is how can we move from that world to a world which I've described here as hyperscale economics. And I think hyperscale economics isn't just about, hyperscale doesn't mean just big. What it means is the scale is different. So the scale between your resource base and your capability base becomes separated. So what you can achieve is either exponential growth in capabilities while maintaining a linear growth in resources, or better still, maintaining a linear growth in your capabilities while actually decreasing the resource base that you need. And I think that's the kind of the fundamental framework that operators need to start to adopt this thinking from the hyperscalers and apply it to our networks. So let's look at how do you begin to apply that? What are the principles and the key findings from our research? And we came back with these 5 kind of key findings, and they are not, they are overlapping, right? So these are not entirely complementary. They do work across each other. The first one, first kind of design and operating principle that we found is think flexibility. So from the outset, because we don't know how demand will evolve and we don't know how those patterns, so think flexibly. The second one is focusing on how we minimize new resources, and those new resources are energy, but they're also new equipment resources, and they're also other fabric of buildings and energy and those resources. I think another key finding that came across quite heavily from our conversations was simplification, the need to simplifying things both from the customer perspective but also within the operator, and that giving us more resilience, better reach, and also improving security. Kind of interesting is how many of the people we spoke to talked about, building the network with AI in automation in mind, so AI-enabled automation in mind. So starting to think now, not necessarily about implementing AI overnight, but thinking, how do I make this network automatable? How do I prepare for an AI-enabled world? And then finally, there were some really interesting findings about unlocking value in existing and new fiber, and how that fiber estate, and in some markets there is considerable fiber, and in other markets it's more of a scarcity, but that also significantly influencing how we think about our network design. So these 5 principles, I'm just going to drill down on each of these quickly in turn. So on the first one here, planning and building and flexibility. On the left here, we have the, as it were, the old world, right? So on the left, it's how a lot of networks were designed and built, and to some extent, that is still true today. We've still designed networks to deliver on-demand content consumption, streaming, applications from the cloud. So there is still a fundamental flow of traffic that we are supporting, and that's how we've been thinking about our network designs to date, with a more centralized architecture and with more predictable traffic patterns. We think, although we don't know, and is we are potentially more distributed because we actually don't know, but we think that there's going to be a more distributed traffic flows. We've seen this already, and Lalit from Lightstorm will talk to this. That there's a lot of traffic between data centers has emerged, which is quite different sort of flows of traffic, and also much more localized, much more distributed, and we need to match those traffic flows with more distributed architectures to deal with that in a more resilient kind of way. So that's the first key principle that came out of the work. The next one, just spend a little bit of time explaining this, is about the focus on emissions. So for those of you who are not familiar, when it comes to reporting carbon emissions, we talk about 3 buckets of emissions. We talk about scope 1, which is the direct emissions from combustion of fuel. So it would be the burning of fuel for vehicles, the use of generators, that's scope 1, so all emissions relating to those activities. Then there's scope 2, which in the case of telecoms is primarily around use of electricity. So it's what are the emissions that are indirectly produced through the consumption of electric power. And that's a fairly significant domain. It's manageable, but it's a fairly significant part of the overall emissions. And then there's scope 3, and scope 3 is, for all operators, it's the biggest component of emissions, and that includes all of the other supply chain embedded carbon within the networks. And so that's everything else, excluding electricity and excluding combusted fuel, but everything else that you have to pull together to deliver your service as an operator. So those are the key ones we're looking at. Increasingly, operators are focusing on that challenging, significant scope 3, but there is still plenty of need to maintain the focus on scope 1 and particularly on scope 2. Now, we're somewhat simplifying things, but how do you think about minimizing those resources? And those resources can be energy resources, which are a significant cost, but they can also be that supply side, in other words, the component resources. How do I minimize the carbon, embedded carbon in my supply chain? And the principles that were discussed with us, one of those is a more modular design. And the notion here is if you can build a more modular design, then the overall hardware life cycle is extended, because you don't have to upgrade everything. You can upgrade what you need to when you need to, and that that modular design allows for a much more incremental renewal rate, but also allows for a much longer life cycle of your equipment. The second one is the second element of that modular design. It helps to reduce the blast zone of a fault, so it has a maintenance benefit too. The second key principle is about more converged architectures, and that's the ability to avoid duplication of resources, avoid duplication of teams and of equipment, and have a more converged architecture. And that can be convergence on a service level, but it can also be a convergence on network layers. And we'll come back to this point in due course. I think a key thing that we've heard a lot from speaking to operators is this need to the physical constraints. And certainly minimize the physical footprint of plant and equipment, and do not extend that physical footprint, because that's concrete and that's buildings, and that has a big knock-on effect on your scope 2 emissions, scope 3 emissions. So there are some significant physical constraints that operators need to maintain, and ideally minimize and even reduce their footprint. And then finally, AI also has a role in optimization, and it has that role on the active infrastructure, and we all know about those kind of sleep modes within our network, but it also has a significant role to play in optimizing the passive infrastructure, our heating, our cooling, and our other estates. So those are key principles for minimizing the use of resources within and meeting our journey. And the next finding from the research, just move on to that quickly, was around simplification for the customer. And that's about having much simpler network designs, borrowing from the lessons of the hyperscalers, where hyperscalers have done a lot to drive down and simplify their architectures within their data centers, within their digital infrastructure. Can we learn from that? How can we adopt some of those concepts and principles? The second key benefit of simplification is it allows us to scale more effectively. So it gives us the flexibility to scale. It gives us what we need in terms of responding quickly. And I think the third benefit that was highlighted in our conversations is if you simplify, it reduces the complexity and also reduces points of failure. And therefore, it can improve your uptime and overall performance. So those are the key elements of that. And then finally, two more elements I just want to cover off quickly. I'm conscious of time. On the next slide, we have we have the use of AI and for autonomous networking, and that's on automating the network. It's on creating new generative AI user interfaces, but it's also about automating the passive infrastructure and energy management systems, as you can see from this quote here. And it's also dealing with increasingly AI-generated customer inquiries. So I think AI is a great tool for us as an industry, but we need to be cognizant that increasingly, we're going to be dealing with AI as a customer. And it's thinking through about if AI, our customers giving AI agency, how do we better support our customers who increasingly will be adopting AI for making networking decisions that we're providing them, and how do we also ensure that our own AI agents satisfy things like SLA. So there's a whole new world of operating models that we need to step up to. Finally, the last of the findings from our research was about existing fiber. And we had some really interesting conversations here with operators, because some operators are in geographies where there is lots of fiber. And when there's a lot of fiber, that does change the way you approach your network design, because it suddenly means that you can think about doing things differently, and you can start revisiting your network architectures. You can start going down the simplification route, and that's going to be quite different by geography. So, but what we did find is that there's obviously more and more fiber available, and as there's more fiber available within the network, so too you can think differently about the network, and it's less of a scarce resource, and you can start adopting different principles when it comes to design. Where there's still scarcity, then obviously that changes it. But there were some interesting findings there about patterns of supply on fiber and how that influences the thinking on the network. Right, I'm going to then move on because I've taken up enough time on my presentation. So in summary, these are the 5 key findings. What we're going to hear now from Amit is how is Juniper thinking about it, providing capabilities to operators along the lines of our findings. So over to you, Amit.
Hi, everyone. Hope you can all hear me. Thank you, Phil. I think that was awesome to talk about all the different things you guys have done the research with the customers. The fundamental issue really is that as the demands continue to grow, and AI is going to make those demands even more exponential from a growth perspective, we need to get to the sustainable, also achieve the sustainability goals, for the networks. I want to talk a few things that Phil mentioned. Just repeat this for a minute, because there's a point I want to make as we go to the AI part of this. We know the traffic is growing, right? We can debate how much the traffic is growing, but during the COVID, it was growing much faster. Then it slowed down a little bit, and now it's going back to the normal rates of growth, right? It's exponential. Video has been the driver for many years. Even after all the humans start watching the video that they can watch and saturate that, we will still have new demand coming from machines who will be watching videos, especially in the AI era, to do some real-time decisions. So this trend of video growth will continue for a very long time. The businesses, what they are doing is they are putting all the applications in the cloud. So literally everything that a business is doing needs to access the cloud, which means all that data growth is coming from the business side too. On the right side, the 2 big things is about data center, right? Because everything is hosted in the cloud, so the traffic in the data centers and between the data center continues to grow exponentially. And then AI is going to add an exponential piece of this, because now we start to see very large models, and these large models share a lot of data between the different GPUs that sit within the data center and across the data centers. So with that, I want to talk about the AI on the next slide before we go to some of the product pieces stuff. Let's go to the next slide. So what does AI mean for networking? There are 2 concepts I want to talk about. One is networking for AI, and the second is AI for networking. But before I do that, I want to compare this AI era with what we have seen in the last 20 years, which was the internet era. What did internet era do? It basically democratized information. right? So everybody could access information in an inexpensive way. Then we had 5G, which allowed accessing that information from any place, anywhere, anytime. Then we got cloud, which made the information storing and accessibility in an inexpensive way, right? By bringing economies of scale. So this cloud plus 5G plus DC era uh, uh, brought a lot of new innovation, right? We got e-commerce, we could watch video anywhere. We had COVID, but we could still work from anywhere. Now we come to the AI era. What AI era, I believe, is going to do is it's going to democratize intelligence, which means people are going to be able to access intelligence in an inexpensive way. It will drive new business models, right? We talk about things like, automated driving, or full self-driving kind of concepts. We talk about extending human lifespans, personal assistance, and even extending the human brain if you are born to be futurist with the man-machine interface. But as we come back to see what this means from a networking standpoint, the first phase of this is what you see on the right, where the training is happening, right? The training of the large models is happening in the big data center, and it's driving large amount of traffic within the data center across the data centers, right? This is so massive that it eclipses everything on the left of it today. But that's not where the money is. That's all cost. Training of models is all cost. The money is going to be in the inference. Let's stay in the previous slide, Bill. The money on training is in the inference. And the inference is basically which is going to happen at the edge of the network, and it's going to happen in the access of the network, even may happen at the customer edge. This is the money, right? As we look at this from a community perspective, I think service providers do have a big opportunity here by looking at inference, that how do they monetize, because all this traffic for inference is going to require SLA, and this traffic is going to sit out, these capabilities are going to sit at the edge of the network. Next slide. So as we look at some of these trends from AI and from the video, next slide, please. We will see different choke points. We are seeing right now choke points at the right end of the network from the DC perspective. We are also seeing choke points at the left of this network, which is in the access space, because the new fiber is still being deployed. I live in the middle of Silicon Valley. I still don't have fiber to my home. And I can believe this is true for many people in this audience. So we have these choke points. When these choke points get filled up, we will have inference coming to the edge and the core, and then those choke points will come up. So we will see choke points at different places of the network at different pieces of time. And the fundamental thing we want to talk about is how to address these, right, in a sustainable way. The number one thing is performance, which we call as flexibility to scale. A silicon and the new speeds and feeds play a big part here. The number two here is sustainability. The sustainability is not just about doing lowest cost per bit. It's really about doing the right tool for the right job, because, for example, in the core, the lowest cost and lowest power per bit is the most important thing. But at the edge of the network, lowest cost per service is the most important thing. So you need to measure the TCO in the right way in the different parts of the network and use the right tool for the right job. And the last piece is operations. And this is where you're going to start looking at AI in terms of what we do with AI for networking to simplify some of the processes for automating the networks. Next slide. So when we look at the implementation of this, we start with the very fundamental concept. We start with the fundamental concept of what is the silicon we need to drive to solve the different problems of the network. At Juniper, we believe we need to use the right tool for the job. You cannot have a Toyota engine in a Ferrari and a Ferrari engine in a Toyota. It doesn't work. And some other guys believe one silicon, but in Juniper, we believe you need to use the right silicon. So we are investing in three classes of silicon. We are investing in MX routers, which uses a trio silicon. And this is the most flexible silicon in the world, because even the silicon which we shipped 10, 15 years ago, we can drive new capabilities in that silicon today, right? Because it is fully programmable. On top of that, it has the scale, which drives the lowest cost per customer and per service. So this is optimized for the edge and has the scale in terms of queues, number of filters, number of services you can terminate. This is the best in the class on the planet. Then we have PTX product family, which uses express silicon. And Juniper invented this class of silicon, and some of the other guys followed us. We invented this class of silicon because we wanted to bring lowest power and lowest cost per bit in the hyperscale bandwidth, locations, which we call as core networks, peering networks, or data center networks, right? So this is the silicon that's focused on that. And then we're not always bound by our silicon. We do use merchant silicon, and we believe that merchant silicon makes sense in some parts of the network, especially in the access and aggregation space, because here we're looking at smaller form factors, and silicon doesn't play that much differentiation there. What's most important there is the software and the capabilities that we drive with Junos, and using different merchant silicon for the smaller form factor platforms in the access and aggregation space. So all in all, our strategy really here is to offer these multiple options to the customers so they can pick the right option for the right place in the network. Next slide. And this is basically showing all the different portfolio. Doesn't show every product on the slide because that would probably be too much. So we're going to say we have the PTX routers now shipping with 800 gig. And these are optimized for the core and peering applications and aggregation in large aggregation applications for service providers. MX with the Trio silicon, both in the fixed form factor and the modular form factors, optimized for the edge for the service terminations, and ACX for access and aggregation with the smaller form factors. On the automation side, we have Paragon solution, which drives all the big pillars of automation and also the AI ops, and I'll talk about that in a few slides. On the optics side, we have invested in our own optics when it comes to the coherent optics. Currently, we are shipping 400 gig optics, and we will soon be having 800 gig optics also for our new 800 gig platforms in the PTX family. Next slide. So I want to talk about this a little bit, which is what we call as the coherent optical routing, or what we used to call as IP over DWDM. In the past, when we did IP over DWDM, we always lost density on the routers, but that is no longer true. Every port that we have on PTX, MX, ACX, this could be a 100 gig port, this could be a 400 gig port, or this could be an 800 gig port, is capable of doing a coherent optical interface just with an optic plugged into that port. So as you look at the two scenarios, in the past, you had to deploy a router, you had to deploy a transponder on muxponder and bunch of optical equipment to basically build a network. That's no longer needed. And this is being driven both in the service provider space and in the data center space with integration of coherent optics into the routers, because first, it drives much better economics. Less power, less space, and less carbon footprint. Some of the numbers are on the slide, and these are very, very compelling numbers. Second, it drives a lot of simplicity because you're eliminating so much stuff from the network and less points of failure, much more stability and visibility into the network. I think this is a no-brainer. And as I look at some of the numbers, how this technology is taking off, the technology is already taken off in the hyperscaler world. But over time, when we look at the numbers from the analysts, the numbers show that the service provider volume will become bigger than the hyperscaler numbers in terms of these optics, because it will be in every part of the network. And as I said, it will be in 100 gig, 400 gig, 800 gig, and in the future for 1.6T and 3.2T also. Next slide. Just a quick view. When you talk about sustainability, it has to come with the numbers. I will not read all the numbers, but I'll give you some examples. Why we drive silicon every 3-4 years? Because as we drive to the next gen silicon, it does give us a better power footprint, right? So for example, today we are shipping our new PTX routers, which is based on the Express 5 silicon. We are seeing 75% power efficiency as compared to the previous generation. And that's true for MX every generation, and that's also true for ACX, which is driving better space and power as compared to the competition, even by using that same silicon because of the software on that. So I think this is the key. And as we bring the optical pieces, coherent pieces, that basically icing on the cake, because that drives even additional power savings to build the sustainable networks and the both silicon as well as the optical piece is key, along with the packaging of this from a product perspective. Next slide. So the product is one part of that. The second part of that is how do we run the networks in the most optimized way, right? So in our Paragon solution, we have the 4 big pillars: planning, orchestration, assurance, and optimization. But what we're looking at this is, when we're looking at this, we're looking at this from a perspective is how do we basically drive different use cases with that? Because the use cases drive the outcomes. So I'll give you a couple of examples from this slide here. First example I'll say is when I onboard something, can I onboard something really, really fast so I can make money and revenue faster, right? So that's driven through Paragon, through zero-touch provisioning to onboard stuff much faster. But really, over time, you onboard it, you provision it. Most of the time, the automation tool is going to be optimizing the network. This optimization comes in 2 ways, 2 scenarios. Okay, there is a closed loop piece, so you take care of your scenarios of failures, which can be automated, the closed loop automation of those. Or you can look at this optimizing how the networks are working. And this is where we bring innovation from a green networking standpoint, because we've added many knobs to our platforms, which can be manipulated by the automation system, which is Paragon, to run the network in the most green way. What does that mean? If something is not being used, we will turn it off. If something is, there is a big difference between day and night, so we can drive lots of savings between how the network is run in the day and how the network is run in the night by turning on and off things to run in the most power optimized fashion. Next slide. I think now you might have heard about Juniper Mist. So Juniper acquired this company, which has been driving AI into Wi-Fi space, into the wired space, and now we are bringing that even to the routing space. Especially this is true for many enterprise customers who, if you have deployed a Wi-Fi and a campus and branch network, with the same Juniper Mist, we can provide routing assurance in the WAN edge for the Juniper routers. So integrating this AI ops, because our routing platforms provide all the telemetry, and this telemetry can be used by the Juniper Mist to provide the routing assurance, just as the Wi-Fi or the wired assurance has been provided. So in the enterprise space, that gives you the single tool. So now we have 2 capabilities. We have Paragon, which does all soups to nuts from an automation standpoint, and using Juniper Mist in the enterprise space, especially providing the AI ops along with, as they have been using it for the wired and wireless space. Next slide. So this is my last slide before we go to the panel. If I can summarize this, there are fundamental pillars of innovation, right? How we can build sustainable networks. It is the silicon, and Juniper is driving the best silicon both in cost per bit and cost per service perspective. We're driving a lot of efficiencies, not only building the right modular and fixed form factor platforms, but also giving the knobs in those platforms to run those platforms in the most power efficient way. So we've got full portfolio with PTX, MX, and ACX. Every port out of our routers is capable of doing DWDM, 100 gig, 400 gig, or 800 gig. And automation is basically that's taking all those capabilities and running the networks in a green way, because by turning off and on knobs at the right time based on the usage in the network itself. So that's my last slide, and then Phil, we can move on to the panel discussion.
Thank you very much, Amit. And I'd like to invite the other panelists to switch their cameras and their mics back on. And I would also like to remind everyone who's joined as an attendee to submit your questions. We've already had 1 or 2 questions come in, which is great. And I would invite you to submit more questions. We will try and get around to the questions in a moment. If we run out of time and we don't have the questions, we will endeavor to respond to your questions that didn't get answered today, and therefore send out the responses after the event. But let's just kick off, and I'd like to just start with our panel with, what do you see as the three big fundamental drivers of change that are driving network transport architectures and thinking, and how will these impact operators? So actually, I'm going to start maybe with Turjay. What do you see as the three big drivers of fundamental change in networking?
Thanks, Phil. So I think actually basically it's almost covered in the introduction and also by Amit, but I can maybe shortly repeat as I see it, and then of course diving into what does it really mean for us as we see it. So when it comes to the three big drivers, I think the number one, which was clearly addressed a couple of times, is the growing traffic. And we can argue about the number. Of course, number of annual traffic growth depends on what countries you are in and also what kind of technologies you're rolling out. So last years, at least in our footprint as Telenor across the different countries, we see roughly something between 20 to 40% annual traffic growth. Not to rest on those, because we see, of course, when we're launching new technologies like launching 5G and those kind of things, there will be a jump in the traffic. So that's the kind of one of the key drivers, of course, the growing traffic in general. And then it's of course this traffic needs to be handled with lowering the cost. So that's also, I think, important. I think Amit mentioned that a couple of times. So and also remember that the cost is composed of capex and opex. So the operational side of this is very important in that sense. The second part of it is that we, I think also actually Amit covered that, is customers want more. They want more than call it only connectivity. So they want actually a solution and experience they can trust. So that means that they typically want, more a bit of managed services. They want a bit more on security. They may want more on insight into self-service. They want support of AI and those kind of things. So that also has a consequence on the capabilities we have to implement in the network and also the support systems. And thirdly is that, and also I think Amit walked through that, is networks need to be automated, they need to be secure, they need to be green, and they need to be resilient. And then, of course, that has a direct consequence on how we are implementing this with the modularity, with robustness, capable of supporting this, for example, introducing all relevant security mechanisms and that part of it. So that's kind of the key drivers, I think. So if I may summarize this, it's simply, high capacity, simplified architecture. I think you call it converged architecture, even Phil earlier. Modularity. We also need to support, personalization. I think two more things I think would add to what you mentioned earlier. I think first of all, resilience. I think we need to be capable of supporting any kind of scenarios, in particular when we are providing, critical infrastructure, and we see that customers are moving on also both mission and business critical applications onto that. And the last part of it, which is probably a new one, is we need network architecture to be able to engage with customers in a different way. Then we call that experimenting, innovating, co-creating, and those kind of things, which is also additional kind of requirements when we see coming from the digitalization across the industry. Call it industry 4.0 or whatever, but it's a different engagement than with customers, and then we need support from the network in order to work in that way. That was very short, I think, on the drivers and some of the aspects we see as a consequence of those.
Well, thank you for that, Amit. And I'd like to, if maybe, if you feel you can, Lalit, can you condense your response? Would you add anything to what Turjay has just said in terms of the fundamental drivers? I mean, you have a different perspective. You're a new operator with a very interesting sort of business profile. What would you say, from your perspective, the big drivers of fundamental change in network transport are?
Yeah, I think the number one for me would be open line systems. Open line systems are becoming more and more. If we have to get the coherent optics to work, what Amit was positioning, and more and more coherent optics is going to be available now. So, they would basically require an open line system. We are seeing a lot of disaggregation of subsea cables. So the subsea cables of the past and the subsea cables of the future completely different. We have a lot more fiber pairs, and the PFE and the SLTs are, disaggregated. You can you can have the SLTs in data centers and build, every service provider can have their own pair of fiber cable. They can run their own protocol systems and services on it, which is very, very different, GTM model than what was prevalent. And the third one, I think, is, a lot more people are trying to simplify the transport network and do away with, with GWDM, any protocols to run on that, so have no control plane, just completely use it as a simple line system and build all the intelligence in the routing plane. So those are the three things that I would say.
Okay, great. Well, I'm going to move those. Thank you both. That's really interesting, and it does sort of tie into what we heard earlier. I'm going to move to Ahmed on the next question, which is, what are the primary sustainability objectives for operators? In other words, for yourself, Ahmed, and for Vodafone, and how are you addressing this in terms of evolving the network and the architectures?
The primary sustainability objective for the operators like Vodafone is reducing carbon emissions and converging energy systems and minimizing electronic waste. And could be by energy efficient modules, reducing power consumption to minimize environmental impact and operation cost, resourcing optimization, just like efficiently utilization network resources, such like a space and power, electromechanical infrastructure, totally circular economy, adopting practical that promote the reuse and recycling of materials by dismantling the obsolete networks and ICT loads. To address this objective, we must deploy energy efficient equipment with high efficiency and low power consumption, implementing visualization and automation, reducing the physical, just like I said, dismantling the old and obsolete infrastructure and management systems, exploring renewable energy sources instead of utility sources.
Great. Well, I think we're going to come back because there's a question that's come in from the audience, which I think is interesting because it relates back to what you're saying, Ahmed. And I mean, the question that the questioner is asking is, do we have any good examples of success stories with how the value chain can work better and collaborate to deliver these sustainable outcomes? So can I ask you briefly to respond to that, Ahmed, and then I'll hand it over to Turjay.
Yeah, it's a good example for sustainability is dynamic thermal management. This is an AI module implemented on the data centers to enhance the cooling system to be more sustainable and reliable for the ICT loads. By reduce and increase the fan speed relative to the heat dissipation required for the ICT.
Okay, great. And you've got examples of where you've worked across the supply chain for that kind of outcome. And I just touched back on you, Turjay. Do you have any case studies where you've worked with the supply chain and collaboration? Any success stories you could point to?
Yeah, just to give you a couple of numbers, maybe, Phil, if I may, as a starting point to give you the context. So if you look at Telenor, the climate, scopes and how is that split into different contributions? It's exactly what you said, I think, in your presentation, that we have roughly 80%, I think, the last time I checked, coming from scope 3. So that means that looking at and collaborating with suppliers is one of the key elements when it comes to that calculations. And then if you look into the energy consumptions, roughly 80% or even 90%, sorry, of that from our own Telenor consumption comes from the network. And then, of course, networks is composed of a number of domains: base stations, transport, mobile core, data centers, and so forth. And then we have the further split into that. But I think it's important not to get lost in this, split into the domains. You need to look at the total network solution. So we're doing that, I think it was 2 years back, and we summarized, the achievements that we have been through at that time, and then we managed to keep the energy consumption roughly flat despite a 200% traffic growth. And
Okay.
that's breaking away exactly from, or you have to break away the energy consumption from the traffic growth, I think, the curve. And how we do that, I think, is the kind of the question next, of course. It's so we sunset old technologies, calling 3G, for example, copper network and those kind of things. We replaced some of the older solutions with newer solutions, becoming more energy efficient, meaning more efficient chips, for example, utilizing sleep modes and lower clock rates and all those kind of things. So that's the kind of the tricks, in quotes, we did in order to achieve that flattish kind of development. And all these kind of things required close collaboration with suppliers, because
Great.
they need to do their part and we can do our part, of course. Yeah.
Okay, well, some interesting statistics there, and that separation of resources from outcomes, really good example. I'd like to come back, Amit, to you. You mentioned several times in the presentation that Juniper's recently announced it's adding 800G coherent optics and pluggables into your portfolio. We did actually discuss this with some of the operators in the research, and to be honest, they didn't see the need for that kind of capacity in their network today. So what's the thinking here?
Okay, thanks for asking that question, Phil. So I give you some examples. First of all, we are shipping 800 gig today, right, on the routing platforms. We are already working with 50 customers across the globe to get to 800 gig deployments. And let me just address the 800 gig specifically, then I'll go to 400 gig and 100 gig. The 800 gig is not just 800 gig, right? I think that's the misnomer sometimes. What does 800 gig bring to the table? 800 gig brings a much better IP over DWDM solution as compared to the 400 gig generation, because the 800 gig optics, DWDM optics, can go even not just metro and regional distances, but also the long haul distances. Right? So that's one thing. Second, 800 gig is also 2x400 gig. It's a much it has discrete fiber ports. It's not a breakout. It's a much better 2x400 gig at a much better power footprint. And then if we go down, it's a much better 100 gig solution also, because you get a lower power footprint with this newer class of silicon. So 800 gig is basically giving you many different things: better 100 gig, better 400 gig, and better IP over DWDM solution. It's not just the 800 gig, which is what some people might be thinking about. And then I want to take out the DWDM question also, because when we talk about the DWDM question is not 800 gig wavelengths. I think now we are at a point where we can do 100 gig, 400 gig, 800 gig wavelengths on every port on the router, because there are optics which are optimized for 100 gig, 400 gig, and 800 gig, which really makes things very, very flexible.
Okay, great. So that responds to some of what we talked about, the flexibility, the scalability, but also realizing that the same technology it is very flexible. It can work across multiple speeds. And Lalit, I mean, I'm interested in bringing you in here because you're dealing with a lot of speeds. You're dealing with these huge connections between data centers, explosive growth. And I know you've looked, you're obviously looking very closely at this. Where's your thinking at regarding the use of speeds and the technologies and coherent optics?
So clearly, the routers where you would need 800 gig ports, if you look at the traditional data center networks, it's, typically they would at max would ask you for a 400 gig port. 800 gig is a unique kind of an ask. And, if you have to really look at, what's really going to come at you are these NVIDIA servers. So one NVIDIA server, let's say H100, it can take up to 3.6 terabyte of, so one server requires that kind of capacity. That itself will take 45 800 gig ports. So what's going to come at us very soon, and that requires a completely different technical skill set in a networking organization to deal with those kind of speeds coming out of a single server. And they have clusters of these servers, and the clusters have to talk to each other. So the leaf spine models are going to fail. They're going to be completely new designs going to come up, grounds up. So I believe that this technology has a great future, when it comes to making AI, democratization of AI. That's going to happen, and that's going to change the dynamics. But if you go and talk to any of the traditional telcos, and we are now 4 years old, you can call us traditional now. We have a lot of customers who do ODU4 services, ODU1, ODU2 services, and those services have to be now circuit emulated into the coherent optics. And the question is, will those will the OEMs build those kind of capabilities into the routers or not? So I think that is kind of a question I would have for Amit.
Yeah, that's a good question, Lalit. So let me start with saying I do have great respect for the fact that service providers do have existing contracts of providing certain set of services. It's not easy for them to turn the contracts overnight like hyperscalers could, right? So there is operational challenge in service provider space to move to a newer technology. But I do believe that, like you said earlier, open line systems. So many service providers are already adopting open line systems. That is the step one to adopting the current technology in the routers. I believe there will be a hybrid approach for a period of time where you do your layer one services because you have the business in the layer one side, but everything else from a routing perspective, you can terminate that current optics onto routers and drive those wavelengths in a cheaper way. Over time, I do believe as the speeds and feeds and the routers grow in the service provider space, the same 100 gig services that you're providing today using wavelengths, you can provide that using Ethernet private lines and give the same experience to the end customers and same cost and power. So I totally understand why most service providers are today, but we are seeing the transition. And I think once that transition happens, this is why I said we're seeing analyst reports that over time, the service provider coherent volume will become bigger than the hyperscalers. And I'm banking on that too myself. I think that will happen.
Amit, with the combination of that prediction and what Lalit's just been talking about, the kind of numbers we're talking about with AI, the growth, the phenomenal growth and the demand for that, and the need to fundamentally rethink the network architectures to serve that, that seems to be a very significant impact coming down towards the industry. Are we ready for that? Is the service provider community? Because up till now, networking, the AI community has focused on silicon, and they've been obsessed with, NVIDIA or whomever. Are they now going to have to start, figuring out networking constraints that they haven't to date, had to worry about so much?
Yeah, I think that's a question for the panel. I think this trend is coming, and Lalit said it's starting from the data center, and anybody in the business of providing connectivity between the data centers is seeing it today. And then as the inference moves into the edge of the network, those demands will move to the edge of the network, and that's where the money is. A lot of people are going to make money in inference, and it's a great opportunity for telcos of the world to figure out how to monetize this transition.
Great. I'm conscious we haven't got much time left. I'd like to put another question here. This is a question from Peter, and he's asking, great innovations and kudos for all the work done. He's saying, whereas you seem to be addressing both the environmental and the governance issues in the telco industry, I would like to hear more about the societal factors, mostly how the employees and staff within the company, how do you engage them? So I'm going to come back to Ahmed. And I'm going to ask, your experience, how do you engage the organization to also sort of step up and support the initiatives around delivering this future sustainable network with this colossal growth? How do you engage the rest of the organization? Ahmed, are you able to share the experience in Vodafone for that?
Yeah. I'd like to say how to engage my company in this, innovations ideas by make a full calculations and assumptions for using automation modules by 4 modules: capacity management, performance management, environmental dynamic thermal management, inventory management. We make a full gap analysis and what if analysis. That's why AI modules produce the gap analysis between the current consumption and the forecast consumption, and what is in the key performance indicators insights with the energy gaps. So I prepare a lot of innovation ideas like UPSs in enhancement efficiencies, DC station enhancement efficiencies, cooling. The cooling is the most practical of the energy consumptions in the data centers. So I prepared all the innovation and make the assumptions for some kind of savings in capex, in opex, as the operational costs, as a capital costs. So I prepare my project or the innovation idea and bring it to the management system. So with the correct predictive savings, and they say yes, we will go with.
Great. So it's using the existing management and governance and supporting around that, and it's also, I think, sharing that with a wide audience. I'm sort of conscious we are short on time, so I'm going to just pick the last question here, maybe, which is there's a question here which is interesting from Rani. So the ecosystem is moving rapidly in generating Scope 3 emissions that are rendering net zero targets unobtainable. Multiple hyperscalers have had to renounce on their previous carbon reduction targets. How do we, as an industry, ensure that we don't fall into the same trap of the hyperscalers, and that we are able, particularly for our hardware-related emissions, how do we enable that we are able to stay on track? So very quickly, how do we do that? You've got a minute each. I'll start with you, Terje. How do we not fall into that disgrace that the hyperscalers have fallen into?
I think if you look into the climate, of course, it's energy source and energy consumptions, and you have to look at both of the sides there. So you also have to engage, with the ones producing energy, meaning renewable energy, and that's what you are doing, for example, through power purchase agreements and those kind of things. Right. But then we are working very intensively on energy efficiency across all network domains, and that also, of course, requires to go into the supply chain in order to make that happen. So back to the question you had before. This has to be shared across, the whole Telenor immediately, across all the units, to make use of the best insights, the best practice how to do that. So that's the way we are doing that. And of course, we have set ambitions and are aiming for delivering on those.
This is a great discussion. I'd like to invite the others, but I'm afraid we have run out of time. But we got some great questions coming in. So those of you who submitted your questions, we will try and get back to you, and we will share the results of the comments with everybody. We will get back to you. Sorry, apologies, we're not being able to answer all the questions. Great submissions from the audience. It leaves me to thank the panel for your contribution, and to thank Juniper for sponsoring this event and for their presentation, and wish everyone a good day. Thanks, everyone.
Thank you. Thank you, everyone. Thank you.